We're going to take a look at open sentences in two variables. So we have looked at open sentences already, but in one variable, like 2x plus 7 equals 5, right? An open sentence, or an equation, really. But now we're going to look at equations or open sentences with two variables. So first, our objectives are going to be to find the solutions to the open sentences as ordered pairs, and then to make sense of those ordered pairs in word problems. A lot of the word problems that we're going to do in these sections, we're going to have to take some of our answers and say, well, this doesn't make sense. Or this answer is not possible, so we need to reject the solution. Because you can't have a negative amount of pencils, right? You might have to reject that solution. Okay, so we're going to keep that in mind as we're going through this, that we make sense of the ordered pairs. First, an open sentence, okay, quickly, is defined as something that has two different variables is said to have a solution as a pair of numbers. A pair of numbers. Where do you see pairs of numbers occur in math? What do we call them, really? Coordinates, okay? Coordinates. So we're going to have two values for these problems. So for example, if we had a random equation like this. I use my initials for middle and first name. So 2m plus 7j equals 20. There's no direct solution to this just by looking at it because there's two variables. So clearly you can't just say, let's solve for m, right? And I'll get the value of m. But what we could do in this problem is come up with ordered pairs. We could say, let m be 1. So we could say, here's our coordinate system in this case. Make believe we're on a m comma j coordinate system. Okay? I could pick a value for m like 2, and then find out what j would turn out to be. And I would have like 2 comma 7 maybe, or 2 comma 9, or 2 comma 12. And then I'd pick another value for m, say 3, and that would be 3 comma 8, okay, or whatever it turns out to be. So for these answers, we're not looking at one answer, but we're looking at actually two values here for open sentences, two values. So let's look at the first example to make sense of this. In the first example, it says find 5 different solutions to this. So you could sit there and find as many as you want, but I'm saying just find 5. Are these solutions going to be unique? No, because there's an infinite amount of solutions. We can get so many solutions here. So just pick a value for x, any value. In your mind, everybody do it individually and write it down. Pick any number for x, doesn't matter what it is. And then find out what y is based on that x. So you pick a value for x. We're not picking the same number as a class. You're all picking your own x. And then we're going to figure out, based on that x value, what is the value of y. So pick a number for x, and you're going to all have different answers, clearly. And then determine what the value of y would be to make this open sentence true. Or to make it a solution, right? When it's a solution, it is true. You could pick an easy number like 0. You could pick a difficult number like 35. You could pick a number that's somewhat in between, like 2, 3, 4. When you pick a negative number.
When it's 5 different solutions, that's like 5 sets of coordinates.
Exactly. Give me 5 scenarios that hold true here. Okay, so come up with 5 coordinates. For now, just 1. I only asked you for 1, but we'll come up with some more. That's all right. You're going to get decimals. You're going to get decimals. No big deal. You can leave it in fraction form as an improper fraction, or you can make it a decimal if you'd like. That's fine. So again, you pick an x value and you give me a y value as a result. Give me an x value, somebody who got a whole number answer for y first. And I got a whole number answer for y, Arthur. All right, so Arthur said let x equal 3. Well, when x is 3, we can go ahead and plug it up here, and we'll see that y turns out to be 4, correct? So y turns out to be 4 when x is 3. So one of our solutions to this, at the bottom here, will be 3 comma 4. That would be one of our solutions. And then we go on until we get how many solutions? 5 for this one, just to go through the process. Somebody give me an example that was not a whole number answer for y.
X equals 1.
What did you get for y?
20 thirds.
20 thirds. Okay, which is approximately 6.7. Approximately. I'm just going to use decimals just for now. Okay, if we round 6.6 repeating. So, in this problem here, now we notice that even though x is a whole number, y turns out to not be a whole number. Not a problem at all. This happens all the time. But this is one of our solutions. So down here we can write, okay? I could start by doing that now. And going on and on and on. Now, if I'm going to do this 5 times, and every time I want to determine the value of y, do I want to resolve this equation 5 times?
No.
So what do we solve for? What do we call it? Who remembers? Solve for the blank solution. For the blank solution. Generic. Very good, Rana. Generic. Okay, generic solution. So instead of plugging in for x every single time and then rearranging and solving for y, start by solving for y initially. So solve this equation for y before you begin. So subtract the 4x. Remember, 4x itself is a quantity. Okay, because x is going to be given a number in a moment. This is like we did with the radius and the height of the cone when we were looking at volume. Same examples. Now I want to get y by itself, so I got to get rid of the 3. So I just put that whole thing over 3. This is the generic solution for y. And that's a lot more powerful than sitting there and plugging in every single time. It's a waste of your time to do that, right? Do you want to plug in for x every single time and solve for y again? No. So you solve generically by subtracting the 4x and then dividing by 3 to get a solution for y. And now you can sit there and just change the value of x over and over again and keep spitting out different y values. Okay, what you're doing is you're writing like an algorithm in a sense. And on your calculator, if you all can take it out real quick, please go to y1. Okay, if you don't have it for some reason, look on. But do not just sit there, look on. Go to y1 in your calculator. So turn it on. And in the upper left of your calculator, you're going to see y equals. So press that. If you get ahead, you can start typing that in already. Put parentheses around your numerator, please. Parentheses around the numerator. So take out your calculator, go to y equals, and type in this function right here that we just wrote down. Here's what it would look like. The x key is located right below the mode key. Folks, the x key is located below the mode key. You have to use that x key.
Than everyone. I have a different calculator. So
Oh, John, I've never seen that before.
it's pretty fancy. That's what my old school required.
Okay, so do you know how to graph on there?
I did last year.
Okay, so you got to figure that out and look for y equals good. So go to your equations and type in your equation.
Okay.
So you need to type in this equation up here.
Wait, should it be after?
But close your parentheses before the division sign. See that? I wrote out the keystroke on the board. If you look up at the bottom right of the board, y1 equals. That's what the keystroke should look like. You need parentheses there. You can graph it if you want. Okay, if you'd like to, you can see what it looks like.
It gives you like 1,000 decimals.
And that's what we're talking about. Hold on. I'll show you how to change that.
Oh, this is so good. He doesn't have the million decimals. I leave it to X. Look at mine. Like when I do that, this is what it gives me.
I'm going to show you a way in a moment.
X is the million. Well, it's not supposed to go there. You just ruined it.
Hit mode on yours real quickly.
Mode? Okay. Okay. And go to your screen. All my values. What is
So,
That's what that is. That's cheating.
here's what I want you to do now. Make it easier on yourself. Look up.
This is so fun.
Go to, first of all, make sure your y equals is correct, okay? Make sure your y equals is correct. Go to your table settings by pressing second and then window. Above window, you're going to see the words TBLSET. That's table settings. So press second and window to bring up your table settings. Okay, to bring up your table settings. This is the screen you should be at right now. Okay, now, Tell me real quick, you need to focus up here. Tell me, did we suggest values for x and determine y, or suggest y and determine x? What did we just do? Yeah, we suggested random values for x and determined the y value. Agreed? Okay. So, x is our independent variable. And we want to ask the calculator a certain value. So go down to independent and go over to ask and hit enter on ask. So it should have ask highlighted and then auto. You're still in your table settings. Come on. Go back to your table settings, guys. Follow directions. So you're going to have it highlighted under ask and then auto. Ask and then auto. Don't worry about the table starting or the delta. Just go over to ask, hit enter, and then have it under ask and then auto. And now go back to your table. You should have an empty table, I hope, right? Everybody should have an empty table. So again, is everybody at this point, did you have ask and then auto? Good. Okay, now go back to your table. So for a second breath, go back to your table, and you'll see an empty table. It's completely empty, right? Now, so type in a value for x. Pick the one we started with, 3. Hit 3 and then hit enter. And notice what it does. It calculates the y value for you.
Wait, I want to see what it would do if I
Okay.
did 6. 1.
Try 1, you should get 6.7 or 6.666 like we were saying. Okay?
This is so exciting.
So, for things like this, okay, you definitely want to still make the table by hand. Folks, pause. I know you're all excited that it helps you save work. That's good. But you still need to be able to make sure that you're solving this way, because you can't do this unless you plug this into y1, right? So you need to be able to solve for y generically. If you can't solve for y generically, then you can't plug this into y1. Again, this original equation or open sentence we started with cannot be plugged into y1. You can't plug in 4x plus 3y equals 24 into your calculator. You can only plug in when it's a solve for y. Is that clear? So you solve for y, and then you can use your table to help you come up with some values. In a moment, this is going to be very useful. So keep this in the back of your mind. Keep your calculator out. All right? Now, again, we wanted 5 solutions, so I would have 3 more coordinates here, and then close my brace. Okay? At the end, I'll close the brace, but there's definitely still 3 more solutions here. But I can't write down what they are because it depends on what you pick for x. Everybody's answers would be unique. Okay? Unless you're given specific x values. With that said, let's look at number 2. 2, same question, but now what are you told? Now what are you told for number 2?
You're given values for x.
Yeah, you're given the values for x. So go ahead and do this on your own, please. Solve for y. Feel free to plug it into y1 in your calculator, and then type in those values for x, -2, 1, 5, and 7, and come up with the corresponding y values. It shouldn't take you long to do this. Okay, the solving is the first part.
My table is only in terms of t, not x and y. So I can only do t.
So, do you have any programs on here that you really care about?
Not hardly.
Whose calculator is this?
Mine.
Is it somebody else's though, right?
Yeah.
And they don't need that? You sure?
Don't need that. Over 3 and then.
Yeah, there's a lot of graphics.
You might do this.
Yeah, you can graphic for each.
I got one.
It's so smart.
It's actually really hard to do.
Actually, no, you got it.
Your parents' class, it was just so
Yeah, that's
really no.
Tests are 60.
All right, let's go through this. Move the 4 over first. The negative 4, move that over. So you get 3y equals 3x plus 4. Again, add that over here. Then divide by 3. Remember, in y1 it should look like this. That parenthesis is extremely important because it tells the calculator to divide the entire numerator by 3. Had it not been there, it would take the number 4 and divide it by 3. Is that clear? That parenthesis is very important, so it knows to divide the entire numerator by the quantity 3 or by the number 3. Okay, so those are our values, or that's our generic solution. What do our values turn out to be? Who's got it for me? Arthur, go.
Well, -2 is like 0.667. Negative 0.667.
All right, so estimating negative 0.7, I'll say.
Yeah.
Okay.
5 was like 0.63.
6.3.
Yeah. 7 was like 8.3.
And then 1 was?
1 was like 2.3.
Good. Okay, those are the 4 values we were looking at here. -2, 1, 5, and 7 for x. And those are the 4 numbers that you end up getting as results. Remember please, that these are approximations because they happen to be thirds, right? Everything's in thirds here. How do you know you're going to get these run-ons? Because look, the whole function is divided by 3. So because the numerator is not divisible by 3, you're going to end up with things divided by 3, which gives you 0.333 repeating and 666 repeating. That's where you keep getting those numbers to appear. Okay, numbers 1 and 2 are pretty simple. Let's look at number 3 now. Let's look at example number. This is one that is more logical. Paul has $22, and he buys notebooks costing $2 each and binders costing $5 each. If he spends all $22, how much of each does he buy? Try and come up with an answer without using any algebraic math. Just do in your head. Come up with an answer, and there's more than one answer, so we'll see that. But come up with an answer, just do it in your head. What's a possible solution for this item? 6 notebooks, 2 binders. I agree, because binders are 5 each and notebooks are 2 each. That gives $22 total. That's one possible solution. Another, Natalie.
4 binders and 1 notebook.
4 binders and 1 notebooks. Well, binders are $5 each. That's $20. And notebooks $2. That's $22. What else?
He buys all notebooks.
Yeah, he buys 11 notebooks and no binders. So how many answers am I going to get for this problem? I'm going to get 3 of them, right? Now, we need to prove that this is actually true real quick to make sure that our answers make sense. What were some of our limitations for this problem? You couldn't have what? What can you not have?
Can't have like half.
You can't have a fraction of an object. So you can't have a half a notebook. So even though you can say, well, let's try 5 notebooks, that's going to give us a decimal value for binders, isn't it? What else can you not have?
You can't have less than $22.
You can't have less than $22 your total. Good. What else?
You can't have more than 22.
You can't have more than $22 your total. Very good. Exactly. One other thing that most people ignore, but it's true. You have to make a statement.
Notebooks cost $2 and the binders.
Oh, that's true. But I mean, what other limitation do you have in this problem? Saying that restricts your answer. There's some sort of domain or range restriction here that restricts my possible solutions for notebooks and binders. We said a moment ago you can't have a fraction of a notebook or binder, right? So we know already that the notebook or binder amount has to be an integer. But what about those integers? Yeah, so what numbers can they be then? If there's no negatives and they're integers, what kind of set is that? What is it? Whole numbers, good. Counting numbers are 1, 2, 3, 4. Whole numbers start at 0, right? So our answer must be in the set of whole numbers. See how the sets come into play now? Okay, again, it's got to be integers initially because they can't be fractions, but you can't have a negative amount. So 0, 1, 2, 3, 4, all those whole numbers are in the set of whole numbers. All right? Anyhow, let's go through this problem and see how it works mathematically. Real quick. If I can get rid of this. Come on. All right. So each notebook costs $2, right? So we're going to say that X is the number of notebooks purchased and Y is the number of binders purchased. So if I bought 5 notebooks and they're $2 each, how do I get the cost of the notebooks? What do I do to those numbers? I bought 5 notebooks, they're $2 each. How do I get the cost? What do? You multiply them, right? So each notebook is $2 per notebook times the amount of notebooks. Binders are $5 per binder times the amount of binders. And that has to equal a total of $22. Again, take a look at your equation here. $2 per notebook times the amount of notebooks, plus $5 per binder times the amount of binders equals a total of $22. This is the way you need to solve these. And some of you have not been doing this on your problems. You've been coming up with the answers like you did a minute ago, which is great. But that's easy right now because this problem is pretty easy, to be honest, and it works out nicely. But it's not always going to be that easy. You need to come up with algebraic solutions so you get your mind trained to think that way. Because you're going to really need that, especially when you get to physics. You're not going to be able to say, oh, well, these are the numbers. Let me just go through it. Now, at this point in time, we can try values for x and y. So if you made a table of values, and you said, well, here's x and here's the y values, what you want to do is try and figure out which of these values turns out to be whole numbers, really. But the problem is that we haven't solved for y. Let's solve for y up here. Move the 2x over. Divide by 5. And that's my generic solution for y. So if you plug this into y1 and then use your table and just simply look at all the values of x, 1, 2, 3, 4, 5, 6, every time you get a decimal for y, you can rule out that answer choice. And you're going to notice that you're going to have to stop at a certain point.